Okay, so this lesson is for Unit 5, Lesson 5. We are solving polynomial equations by factoring. Now, the last two videos covered factoring polynomials, where we introduced two new types of factoring, factoring with sum of cubes and difference of cubes. And then we did a little bit of different things with our 1, 2, 3 factor trees with fourth power degree trinomials. And it worked pretty much the same way as our normal 1, 2, 3 factor tree. Okay, so today we are solving the polynomial equations by factoring. So that's why we practice the factoring so much. So solving by factoring. So remember, solving is the extra step where we t-bar it. We set the equation equal to 0 after we factor, and we t-bar and we solve for x. So we're just adding a little bit to what we did in lesson 4 of this unit. So our steps to solving this: first, we're going to move all terms to one side so that we are equal to 0. And that's a pretty understandable rule. We can never factor unless we're set equal to 0. Step 2, we're going to factor the polynomial completely. So we have quite a few choices: greatest common factor. And remember, we check for that first every time. It can show up along with another type of factoring. Difference of squares. 1, 2, 3 factor tree, sliders with a factor tree, sum of cubes, difference of cubes, factoring by grouping. Those are all of our choices. We have to be able to look at the polynomial based on how many terms are in the polynomial. We have some clues, but then we have to pick the right method. And then after we've factored it completely, we t-bar. We set each factor equal to 0 and solve for x. Now, because we're dealing with higher degree problems, we will sometimes have to use square roots to solve for x after we've t-barred. I'm not really going to show it with complete the square, but we will have to use quadratic formula a couple times. We will have radicals in our answer, so make sure you're using a Casio if that is hard for you to do. Okay, complex means we will have imaginary solutions as well. So here we go. On number 1, our polynomial is x cubed plus x. So we have two terms, but a first thing I always check for is a greatest common factor. And I have a greatest common factor of x. So I'm pulling one x out of each term. So that will look like x and then parentheses x squared plus 1, because we did x divided by x, and it's equal to 0. I would check inside the parentheses. X squared plus 1, okay, they're two perfect squares, but it's a plus sign in between, so I cannot factor anymore. If you cannot factor anymore, you t-bar. Remember, after you t-bar, we're finding solutions, or where these equations would cross the x-axis. We set each side equal to 0. So I say x equals 0. Now there's nothing left to solve for x. X is by itself. So one of our solutions is 0. And then I take my x squared plus 1 and set it equal to 0. I need to solve it for x. So our first step would be to minus 1. If we have x squared equals negative 1, again, I'm not solved for x yet. I'm solved for x squared. So we take the square root of both sides. So this would become x equals, whenever we're taking the square root of our equations, we're going to put plus or minus. Remember, the negative from underneath the radical always turns into an imaginary number. So I would think of this as I square root 1, and the square root of 1 is 1. So I don't need to put a 1 here. It's just plus or minus I. Okay, number 2, we have 4x cubed minus 7x squared equals 3x squared. So again, this is not set equal to 0. So our first step is to bring that 3x squared over to the left side. So we're going to do that by minusing, because that's the opposite operation. It matches up with the negative 7x squared. So our new equation is 4x cubed minus 10x squared equals 0. Now to start my factoring, I'm going to start by checking for greatest common factor. Okay, the largest number that goes into 4 and 10 is 2. And if I have 3 x's and 2 x's, they can both give me 2. So dividing by 2x squared leaves me with 2x and then minus 5. And it's equal to 0. I'm checking this 2x minus 5, see if it can be factored further. Now notice x does not have an exponent, so really I can't do anything else to that part factor-wise. So we t-bar. And each of my factors, 2x squared is a factor. I set it equal to 0, and I solve for x. So I first divide by 2. 0 divided by 2 is still 0. And then I square root both sides to solve for x. The square root of 0 is 0. It's not even plus or minus 0, just 0. So we have one of our answers. 2x minus 5 equals 0. Again, solving for x, so we add 5 first. So if we have 2x equals 5, we get x by itself by dividing both sides by 2. So our second answer is 5 halves. All right. Hey, number 3, we have x to the 4th minus 64. All right, we are set equal to 0, so that's step 1. It's done. I'm looking for a GCF. I have x to the 4th and 64. Okay, I have a variable term and a constant term. There's nothing in common, so no GCF on this one. So then I'm checking. Okay, 64 is a perfect square and a perfect cube. So am I doing, okay, this is a different sign. If it's a minus, am I doing difference of squares or difference of cubes? And that is kind of told to me by this exponent of 4. Okay, 4 is even. Okay, it's not 3, so it's not a cubed. But all even exponents are perfect squares. So we are doing difference of squares factoring here. So 2 sets of parentheses. We're going to put opposite signs in the middle because that's the rule for difference of squares. And then we get what goes in by square rooting. The square root of x to the 4th is x squared. The square root of 64 is 8. Okay, I'm checking my x squared with a minus sign to see if I can do difference of squares again. 8's not a perfect square. So we are ready to t-bar this to get our solutions. So for my first factor, we have x squared plus 8. I set it equal to 0 to find its solution. We would minus 8 to both sides, and 0 minus 8 is negative 8. And then we would square root both sides. So we would have x is equal to, I'm going to automatically put a plus or minus. The negative is going to come out as an I. So you would put into your calculator, remember, thinking just the square root of 8. And that simplifies to 2 square root 2. But we have to put the I back in. So it's plus or minus 2I square root 2. Okay, and this counts as 2 answers because we have a plus and a minus of it. That's 2 different numbers. My second side, we have x squared minus 8 equals 0. So this time we would have to add 8 to both sides. So x squared is equal to positive 8. It's a very similar answer, but this time we don't have a negative underneath the radical. We're taking the square root of positive 8. So we get x is equal to plus or minus still, and the square root of 8 is still 2 square root 2. Now these are 2 different answers. The imaginary is different than the real part of it. Now I want to point out that this started off as a 4th degree polynomial. Remember that the highest exponent in the polynomial tells you at most how many answers you can get. So at most we could have 4, and we do have 4 answers here. Plus or minus 2I square root 2 is 2 answers. Plus or minus 2 square root 2 is another 2. So we did get 4 answers there. Okay, moving on to number 4. We have 5x to the 5th minus 80x. So again, this is a 5th degree. So at most we could be having 5 answers. Let's see how many we do get. I have it equal to 0 already. So now I'm checking for a greatest common factor before I do any other type of factoring. We could take out a GCF of 5x. So when we do that, we have 5x, and then we're left with x to the 4th minus 80x divided by 5x is 16. And it's equal to 0. Now, we took out a GCF, but now I'm looking inside. X to the 4th minus 16 is still has more factoring to do. It's a difference of squares. So we'll say this is 5x, x squared plus 4, and x squared minus 4. And then, because I still have x squareds in my factor, I'm looking. This piece right here has that extra part where it could be factored again. So we have 5x. It's x squared plus 4, and this part factors to x plus 2, x minus 2. And it's all set equal to 0. So we have a lot to t-bar here. So we t-bar, when we do that, we're in between every single factor. Now over here, we would say 5x equals 0. To solve for x, we would divide by 5, and 0 divided by 5 is still 0. That's one answer. In my next section, I have x squared plus 4. That factor, to get its answer, we have to set it equal to 0. So we would minus 4 from both sides, and 0 minus 4 is negative 4, and then square root both sides. Well, that gives us x equals plus or minus, because we're doing a square root. The negative comes out as an I, and the square root of 4 is 2, so it's plus or minus 2i. This counts as 2 answers. So now we're up to 3. If we say x plus 2 equals 0, we would subtract 2 from both sides and we get -2. There's our 4th answer. And x minus 2 equals 0, we would add 2 to both sides to give us +2, our 5th answer. So again, you could, I don't mind if you box up your answers like this or circle them. You could also write it as a solution set, which is the most proper way. We would say that we have 0 plus or minus 2 plus or minus 2i. Okay, that's our solution set. But I'll take it either way. Okay, I'm going to skip over number 5 and I'm going to go to number 6 for our next example. We have 8x to the 5th plus 5x squared equals 4x squared. So remember, our step 1 is to get the equation set equal to 0, so we need to subtract 4x squared to the left side, giving us 8x to the 5th. 5 minus 4 is a +1 x squared, and now it's equal to 0. Okay, to start off my factoring, I look for a GCF. I see that they have an x squared in common, so we're going to divide that out. It's x squared, and then we have 8x cubed left over plus 1. So now when I check out the inside of these parentheses, I can see, or hopefully you can see, that I have 2 cubes with a plus sign in the middle. Okay, so we are doing sum of cubes, and that's a little bit newer one. And that formula goes a plus b, and then we have a squared minus the a times the b plus the b squared. So we need to know what our a and b values are. Okay, a is the cube root of the first term. Okay, we were given 2 cubes. We need to get back to their bases, their original amount. So the cube root of 8x cubed is 2x. 2x will go in for every a. Our b value is the cube root of the second term. So the cube root of 1 is 1. So 1 goes in for every b. So when we fill this in, okay, I'm going to remember that we have that GCF of x squared on the outside. We have x squared, parentheses, a plus b. It would be 2x plus 1. Then we start a new factor. It's our a value squared. That's 2x times 2x for 4x squared. Minus sign, a times b is 2x times 1 for 2x. And then plus sign 1 squared is 1. Okay, this is all equal to 0. Now we t-bar our factors to solve. My first factor is x squared equals 0. Okay, if we have x squared equal to 0, we square root both sides and we end up with x equals 0 as our first solution. For the middle piece, I have 2x plus 1 equals 0. We would subtract 1 from both sides, and then we would get 2x equals -1, and then divide by 2. So another answer is x equals -1/2. Okay, now my last section for getting my solution is this piece right here, 4x squared minus 2x plus 1. Now look, my exponent is squared, and we call that quadratic, and there's 1, 2, 3 terms. We would love it if we could do a 1, 2, 3 factor tree to finish solving for x. But remember, when we learned this, we learned that when we did sum or difference of cubes, once we applied the formula, there was no other factoring that could be done, no extra factoring. If 1, 2, 3 factor tree worked, we would have already had to have done it when we just did regular factoring. So this part right here, always for sum and difference of cubes, when we want to solve it, we can only solve it using the quadratic formula. Okay, and we're always going to get some imaginary answers. I'm spelling that wrong. Imaginary. Okay, answers in here. So I'm actually going to come and work over here. And the quadratic formula, if you do not remember, goes -b plus or minus the square root of b squared minus 4ac, all being divided by 2 times a. So we're going to plug our a, b, and c values from this equation, again right here, into the formula. So a is always the coefficient or number in front of x squared, so it's 4. B is the coefficient of x, it's -2. C is the constant, it's 1. So we will get x is equal to negative and then -2 plus or minus square root of -2 squared minus 4 times 1 all over 2 times a, which is 4. Now, Again, I said these are imaginary solutions. So your Casio, most Casios, unless you have the 115 ES, it won't do imaginary solutions. So we have to work it down a bit before we can type it into our calculators. So your first part, negative negative 2 turns into positive 2. Okay, plus or minus. What is the negative number that's causing all the trouble? What does negative 2 squared minus 4 times 1 equal? It equals negative 12. So we'll put it underneath the radical. And then I'm going to multiply the denominator. 2 times 4 is 8. So here's what we're going to do. You're going to remember that the negative underneath the radical comes out as an I. And in your Casio, you would type in 2 plus, because there's not a plus or minus button, square root positive 12, and then we'll put it over 8. We'll put this right here all into our calculator without the negative sign because we need it to simplify the radical and our fractions. And what your calculator tells you, okay, what your calculator is going to come out as, the answer will be 1 plus the square root of 3 over 4. And you're going to have to remember, we took out the negative, so we need to replace this I back in there. So we'll put it right here. And the quadratic formula used plus or minus. Calculator doesn't use plus or minus, so we'll change that to plus minus right there. So these count as 2 more answers in our solution set, along with 0 and negative 1/2. Okay, the next example we'll do is number 8. We have 16x cubed equals 54. So again, before we can do any factoring, we have to get equal to 0. So we're going to start off by subtracting 54 from both sides. So this is 16x cubed minus 54 equals 0. Now I have an x cubed and a minus sign, so I'm thinking difference of cubes, but 16 and 54, they don't have a whole number or an integer to be their perfect cube. So we're looking for a GCF, and that would be 2. So we're going to have 2, and that leaves us with 8x cubed minus 27 after we divide that GCF of 2 out. So again, I have a minus sign, which is a difference, and I have a cube on either side. So we're using difference of cubes here. So the formula for difference of cubes is almost the same as sum of cubes. We just change where the minus sign is at. It goes a minus b because we're differencing first. And then it's a squared plus a times b plus b squared. So because we need to plug values in for a and b, we need to know what they are. So a is the cube root of my first term, which will be 2x again. B is the cube root of 27, which is 3. So 2x goes in for every a, 3 goes in for every b. And remember, we had a GCF of 2. We'll bring it down. And then a minus b is 2x minus 3. A squared is 2x times 2x for 4x squared. A times b is 2x times 3 for 6x. And b squared is 3 squared. That rhymes, which is 9. And it's all equal to 0. So we're going to t-bar again after we're done factoring. Okay, 2 equals 0. 2 does not equal 0, and there's no x to solve for. So this GCF does not give us a solution because there was no x attached to it. 2x minus 3 equals 0. We have to solve for x, so we add 3 to both sides. Whoops. So we get 2x equals positive 3, then divide by 2. So our first answer is x equals 3/2. Now again, because I did a cube type of factoring, sum or difference, we did difference here, this part can only be solved again by that quadratic formula. So I wrote the formula down on the other page if you need it, but we need our a, b, and c. A is our 4, it's in front of x squared. B is 6, c is 9. It's already in ABC order. So in the formula, we'll have negative 6 plus or minus the square root of b squared would be 6 squared minus 4 times 4 for a times 9 for c all over 2 times a, so 2 times 4. Again, this will yield imaginary solutions, so we're going to simplify it in parts. This stays negative 6 plus or minus little radical. 6 squared minus 4 times 9 equals negative 108. That's what we'll put underneath the radical. All over 2 times 4 is 8. So again, you can't put this negative in the calculator. Just remember, it comes out as an I. If you type in just -6 plus the square root of 108 over 8, you will get out, you'll say -3 plus 3 square root 3 over 4. And you have to be so smart like you are, and remember we got to put that I back in there. So it goes right here, and it's plus or minus. So this is our second and our third answer for x. And remember, you only have to use a quadratic formula for problems that involve solving when you did sum or difference of cubes factoring. Okay, our next example will be number 9. Okay, so on number 9, we are set equal to 0. We have x to the 4th plus x squared minus 42. Now notice I have 1, 2, 3 terms. So we call it 1, 2, 3 factor tree. And even though we start with the 4th power here, we have a squared that follows it and then a constant. We are still quadratic in nature. We can still remember that x squared times its own self, x squared equals x to the 4th. So we can still work our factor tree magic here. We're looking for two numbers that multiply to -42 and subtract to 1. Those two numbers will be +7 and -6. But again, I said x squared times x squared makes x to the 4th. So we have to write it as x squared plus 7, x squared minus 6 equals 0. So we have it all factored. This is a lot easier after the last two problems we've done. We can t-bar it. We set each factor equal to 0. So x squared plus 7 equals 0. We minus 7 from both sides, and that gives us x squared equals -7. And then square root both sides. So x will equal automatic plus or minus when we square root a side. The negative comes out as an I, and the square root of 7 is the square root of 7. So our answer is plus or minus I square root 7. On the right side, we have x squared minus 6 equals 0. We would add 6 to both sides to get x squared equals 6. Square root, square root. There's no negative this time, so no imaginary. So we have x is equal to, the square root of 6 is plus or minus, and it stays square root 6. So these are our 4 solutions. Okay, our next example is number 12. So I look and I have 2x to the 6 minus 10x to the 4th minus 48x squared is equal to 0. So we are equal to 0. I count my terms. 1, 2, 3. I want to do a factor tree. Okay, we can't do that unless we get rid of the 2 in front of as our leading coefficient. So we check for GCF. I can take out a 2 out of 10 and 48. And I notice they all have x's in common. I can take out a 2x squared. So that will be the GCF. And then we'll have x to the 4th left minus our middle term divides out to 5x squared, and our last term, -48x squared divided by 2x squared, is -24. Okay, now that we don't have a leading coefficient greater than 1, we can do 1, 2, 3 factor tree, looking for what multiplies to -24 and subtracts to -5, and that would be a -8 and a +3. So in factored form, we have 2x squared. That GCF just keeps coming down. Again, this is x to the 4th, so in our factors we have x squared minus 8, x squared plus 3. Because remember, if we FOIL back out, we do x squared times x squared, we have to get back to the original, and that's x to the 4th. So now let's t-bar it. None of these can factor any further. I set 2x squared equal to 0. Solving for x, I would divide both sides by 2. 0 divided by 2 is 0. Square root both sides. So our first solution is at 0. If I have x squared minus 8, set it equal to 0, I would add 8 to both sides. So x squared equals 8. And then square root both sides. So x is equal to, because I involve square roots again and it's not 0, I put plus or minus. The square root of 8 is 2 square root 2. So we have 2 more answers. And then last, we have x squared plus 3 equals 0. So we would minus 3 from both sides. X squared is equal to -3. And square root. X equals plus or minus. The square root of a negative always has an I. So square root of 3 stays the square root of 3. So again, whenever you're using radicals, make sure to use your Casio. Okay, next we'll do 13. We have 3x to the 4th minus 2x squared equals 16. It's not equal to 0, so that's our first step, to minus the 16 over. So this is 3x to the 4th minus 2x squared minus 16 equals 0. Okay, I have 1, 2, 3. I want to do a factor tree, but I have got this 3 in front of x to the 4th. It does not divide into 2 or 16, so it's a slider. We're going to take 3, slide, and times it to 16. So it's x to the 4th minus 2x squared, and 3 times 16 is negative 48. It's all equal to 0. So now we can do our factor tree, looking for two numbers that multiply to negative 48 and subtract to negative 2 would be positive 6 and negative 8. So because we start again with an x to the 4th, this will be x squared plus 6, x squared minus 8 equals 0. And we had a rule, if we slider, we have to divider. We're dividing by the slider, which was 3. Simplifying our fractions, 6 over 3 simplifies to 2. 8/3 does not simplify, and because I'm pulling my solutions out, I do not need to go bottoms up. We only do that if we need to leave our answer in factored form. So t-barring, we have x squared plus 2 equals 0. To solve for x, which is the whole goal, we minus 2 from both sides, so x squared equals negative 2, square root both sides, so x equals plus or minus I square root 2. Okay, if I have x squared minus 8/3 equals 0, we add 8/3 to both sides, so x squared equals positive 8/3. And notice we are square rooting the whole fraction. Okay, so x will be equal to plus or minus. Now that's, again, using your Casio. Your Casio will do something called rationalize the denominator, which is actually more part of our next unit in 6. So trust your Casio for now. This is 2 square root 6 over 3. And these are 4 solutions. Okay, number 15, we're going to solve by factoring by grouping because there are 1, 2, 3, 4 terms. So when we factor by grouping, our first step is to cut our equation into 2 groups. Cut it in half, 2 terms on either side. And then we're taking a GCF out of each group. So my first grouping, my greatest common factor from x cubed and 2x squared is an x squared. So if we take 2 x's out of each, we're left with 1x and then plus 2, which we wrap up in parentheses and we put x squared on the outside. I look at my second grouping, 5x plus 10. Its GCF is 5. 5x plus 10 divided by 5 is x plus 2. We put our plus 5 on the outside. Now remember, your self-check is to see if you got what was in the parentheses to match. We did. So that's just x plus 2, not squared. It's a different type of factoring here. It just means we're doing it right. And then our 2 GCFs hook up. So we have x squared plus 5 together. This is all equal to 0. Okay, we have our 2 factors, and now we're going to t-bar. We set x squared plus 5 equal to 0 and solve for x. So we minus 5 to both sides, and it will be x squared equals negative 5. And square root both sides. So x equals plus or minus, the negative comes out as an I, and the square root of 5 is the square root of 5. So those are our first 2 answers. We need one more, because this is a 3rd degree polynomial. If I have x plus 2 equals 0, we just have to minus 2 from both sides. 0 minus 2 is negative 2. We are not square rooting because x was not squared. It was just a regular old x, and this is done.